See, what I was telling you, if the difference in electronegativity between two elements is equal to 1.3. Since difference in electronegativity is less than 1.7 now, so it should
Yes,
be
sir.
covalent. It should be covalent. But your
Yes, that's
answer,
what I got.
38% was covalent and 62 will be ionic now. So it won't be covalent, it will be ionic now. Majority is of ionic character now. So
Yes, sir.
that's a mistake you did. See, if the difference in electronegativity is 1.7, then the percentage ionic character will be 50. And if it is 1.3, if the difference in electronegativity is 1.3, then the percentage ionic character will be 50 into 1.3, 50 into 1.3 divided by 1.7. So it will be 38% ionic. Just please check. I don't know how much it is. I don't know how much it is.
Yes, sir.
38% ionic. And 62% will be covalent. But your answer was opposite.
Yes, sir.
Fine. So just no issue. Since we are doing first time all these type of questions, that's why there is probability of making mistakes like this. Is this all okay, man? This
Yes, sir.
electronegativity, that's the most accurate answer. That's the most exact answer. Fine. Now
Yes,
see.
sir.
Now see. What is the valency of sodium? Now, one last point, one more very important point. What sodium is? Valency of sodium is 1. What about the valency of oxygen? 2. On the very first day, I was asking you this all, and you are giving me all these answers very right, very accurate, man. Even 12th class students don't give this much accurate answers. Fine. So that was the reason I was very happy. Because if you are accurate one, then obviously teacher will enjoy a lot teaching you, no, man. Now see, what about the copper? Copper valency, sometimes it is 1, sometimes it is 2. What about Ag? The valency of Ag, sometimes it is 1, sometimes it is 2. We need to learn this all. Obviously, laterwards in coming chapters, I'll explain this all. Then it will be easy for you to manage this all. And the valency of Au, sometimes it is 1 and sometimes it is 3. What about the valency of Fe? Sometimes it is 2, sometimes it is 3. These are D block elements. What these are? These are D block elements. What about these are? This is S block, this is P block. These are S and P block elements. These are S and P block elements. What about the D block elements? D block elements always show variable valency. What they always show? Variable valency. Sometimes 1, sometimes 2. Means variable means changeable, na? Different, na? Not fixed. Na?
Yes, sir.
Sometimes 1, sometimes 2. 1, 2, 1, 3, 2, 3. But in most of the compounds, copper shows 2 valency. Most of the compounds. 1 is also there, but in most of the compounds it is 2. Ag, in most of the compounds it is 1. Au, in most of the compounds it is 3. Fe, in most of the compounds it is 2. I am not saying this 2, 1, 3 and 2 will be more stable. I am saying it is more common. This encircled na is more common, means in most of the compounds it will be showing all these oxidation states in most of the compounds. Is it okay, beta?
Yes.
Today I told you 4 elements. Some other day I'll tell you 3, 4 more elements. That's all. Chemistry will get over. That's all. In this way we will learn. I have told
Yes,
you
sir.
about these 4 elements. So in next class or in coming classes, you should know these 4. What about the rest? That is my problem. I have not done that. So how we can come to know about that? Once I'll explain all those things, then you will also be there in a position to tell me all these things, all those things. Are you getting? So we'll take
Yes,
time.
sir.
We'll take time. Overnight, it won't be possible. We'll take time. Fine. What we are doing, that is very, very good, man. Very, very means if you'll keep on doing like this, then it will be very easy for you to enjoy chemistry. Fine. See. Uh, is this okay, man?
Yes, sir.
Here you have written variable valency. What about the valency of S and P block elements? What about the valency of S and P block? Here for D block elements, you have written variable valency. What you will be writing for S and P block elements? Their valency will always be group valency. Their valency will always be group valency. It can't be variable valency. It can't be variable valency. Are you getting this all?
Yes, sir.
This point is there in our books, but never any student gave me. I'm not talking about 10th class students, even 11th, 12th class students, even IIT, JEE students never gave me this answer. But it is there in your basic course book. Then also they never gave me this answer. Why? Because their teachers are not telling them this term. That's why they never come to know about this all. But you should know. I won't be writing. I'll be asking you what is the valency of sodium. Then you will be saying 1, but I won't be giving you that option 1. So how you can write that one answer? So then what you have to write? You have to write group valency. I'll be asking you what is the valency of oxygen, and you will be telling me 2, but I won't be giving you that 2 option. So then what answer you will be writing? You will be writing group valency. Is this okay?
Yes,
So
sir.
opposite of variable valency is not non-variable valency, is not fixed valency, is not constant valency. It is group valency. Opposite of variable is non-variable, that is English, and we are not doing English. Opposite of variable is constant, is fixed, but that is English, and we are not doing English. We are doing chemistry. So in chemistry, opposite of variable is group valency. Fine. Now see,
Yes, sir.
what have you written? You have written D block elements. You have written D block elements show variable valency. D block elements show variable valency. What's the meaning of variable? Variable means many. Variable means many, more than one. More than one, out of more than one, one will be the lower oxidation state, lower valency, and second will be the higher oxidation state, higher valency. Are you getting my point?
Yes, sir.
See, this is lower, this is higher, lower, higher, lower, higher, lower, higher. Lower doesn't means 1, lower doesn't means 2, lower doesn't means higher, lower doesn't means 2. Lower means if suppose 5 and 7, this is lower and this is higher. Is this okay? In lower oxidation state, it will always be showing basic character. It will always be forming ionic bond. In lower oxidation state, it will always be more ionic, and in higher oxidation state, it will be more covalent, it will be more acidic or more covalent. More acidic or more covalent.
Yes, sir.
Is it okay, beta?
Yes, sir.
See, you scored 91%. Your friend scored 90.99%. Are you getting my point?
Yes, sir.
You scored 91% and your friend scored 90.99%. So your friend scored lesser than you. But it doesn't mean she is a weak one. She is dumb. She is duffer. She is poor. No. Lesser than you. But both have done pretty well. Are you getting?
Yes, sir.
So that's a matter of relativity. So this will be more ionic. More ionic doesn't mean ionic. More ionic means in compared to this, it will be more ionic. If this is 0.11% ionic, if this is 0.11% ionic, this will be 0.12% ionic. Sorry, this is 0.12% ionic. Then this will be 0.11% ionic. But see here, 0.12% is ionic, but 99.88% will be covalent now.
Yes, sir.
So here you are comparing these two things. More ionic doesn't mean ionic. More covalent doesn't mean covalent. Is it okay?
Yes, sir.
In
Yes, sir.
first half, Babu, you have said that S and P block elements will form ionic bond. Ionic or electrovalent bond. This we have written now.
Yes, sir.
What about D block elements and P block elements? P block elements plus D block elements, they are in lower oxidation state, will form ionic bond. Which bond it will form? Ionic bond. And P block elements
Yes.
plus D block elements, they are in higher oxidation state. They are in higher oxidation state, will form covalent bond. Is this all okay?
Yes, sir.
Now see, the next one. Ionic bond is total all over. You should go through your book, and if something is not done or if some doubt is there, just please ask me. Fine?
Yes, sir. Yes, sir.
Exercise as well as theory, everything you should do and then ask me the doubt. Now see, P block elements, now see, covalent bond. Now see, ionic is over. Now see covalent bond. Covalent bond. If P block elements combines with P block elements, or if non-metal combines with non-metal, if electronegative element combines with electronegative element only, see, nitrogen is electronegative and oxygen is also electronegative. If both will combine, then which bond will be formed? Covalent. P block elements plus P block element, non-metal plus non-metal, electronegative element plus electronegative element. Then high ionizing energy elements plus high ionizing energy elements, then the bond formed will always be covalent bond. Covalent bond. Is this okay, beta? If the difference
Yes,
in
sir.
electronegativity between the two elements is less than 1.7, then the bond formed will always be the covalent bond. These points are not so good. These points are not so good. This is the ultimate point, but it's difficult to. This is the ultimate point, but difficult to. Then
Yes, sir.
I have already said P block elements plus D block elements, they are in higher oxidation state, bond formed will always be covalent bond. Not only beta, from 10th class point of view, you have even finished from even 11th class or higher classes point of view too. Everything is done. Up to IIT JEE level, it is done. Nothing else you will ever come to know about more than this all about covalent bond or ionic bond. Never. So everything is done. Fine. So this all is done about covalent bond and ionic bond. Now see, there is one more very difficult point, but if you'll do that, then it will be very easy for you to manage chemistry. See, boron, aluminium, gallium, indium, thallium, then carbon, then nitrogen, then oxygen, then fluorine, then neon, then helium, argon, krypton, xenon, radon. My memory is not so good, but see, still I remember this now. So you have to take interest. Then only you can remember it. It's not a matter of memory. It's a matter of interest. If you'll have interest, then automatically it will be easy for you to remember. If you do not have interest, then obviously it will be difficult for you to remember. Then carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, chlorine, bromine, iodine, astatine. Now see, atomic number of boron is 5. 5 plus 8, 13. 13 plus 18, 31. 31 plus 18, 49. 49 plus 32 will be 81. This is 81, so obviously this will be 82. This will be 83. This will be 84. This will be 85. This will be 86. Need not to remember, na? Need not to learn. Just only this is required. 5 plus 8 plus 18 plus 18 plus 32. That's all. That is what I do. I don't remember this all, but I am adding this all very fast. 5, then obviously this will be 6, 7, 8, 9, 10, 2, 18, 36, 54, 54. Yeah, I'll tell you. 53, 52, 51, 51, 50. Fine, 31, 32, 33, 34. This is 18, 17, 16, 15, 14. Yeah, you were asking me something?
Yes, sir. So it goes up in like the valence shell number of electrons, right, sir?
Yeah, that we should know. That we should know. You know, this is steps na, stairs na.
Yes, sir.
Fine. In first step, only one box. In second step, two boxes. In third step, two boxes. In fourth step also, two boxes. And in last step, just only one box. First is 1 and last is also 1. Rest were 2, 2, 2. So total 8 elements are there. Na? What you are doing, you are drawing just only P block elements. Just only you are writing this P block. These 8 elements are metalloids. These 8 elements are metalloids or semi-metals. These are metals and these are non-metals. What these 8 elements are? You'll start from here, boron. Excuse me. Just only one element. Next, go down, 2 elements. Next, go down, again 2 elements. Next, go down, again 2 elements. Last is 1 only. Last is 1 only. These 8 elements are metalloids. These 8 elements are metalloids. See, this bismuth is having 5 electrons in the last shell. This bismuth is having 5 electrons in the last shell, but is a metal. Why? Because all these are metals now. Irrespective of the number of electrons there in the valence shell, are metals. Bismuth is having 5 electrons, but is a metal. Tin and lead are having 4 electrons. Tin and lead are having 4 electrons. but are metals. But are metals. Why? Because these elements are placed on the left hand side of this strip there in the periodic table. All those elements which are placed on the left hand side of this strip there in the periodic table are metals, and those which are there on the right hand side of this strip are called non-metals. Since bismuth, tin, lead, all are placed on the left hand side of this strip, that's why are called metals. That's why are called metals. Is it okay, beta?
Yes, sir.
That's all, ma'am. So now you should tell me in next class, sir, this related to ionic bond, you have not explained. This related to covalent bond, you have not explained. This question I am not able to do. So in this way, we'll do this all, and then we'll start the next topic. Fine. Up to any
Yes, sir.
level, up to any level, covalent and ionic bonding is done. But it should be good in electronic configuration. And if still you have some difficulty there in that electronic configuration, just please let me know. Just please let me know. In this way, we'll complete everything. See, fine.
Yes, sir.
So if this bonding is good, then your chemistry will be good. If bonding is not good, then you will be facing a lot of difficulties there in the chemistry. Chemistry is all about electronic configuration. Chemistry is all about chemical bonding. Chemical reactions are all about chemical bonding. Fine. That's all for today. So in next class, we'll continue the same. I'll forward you some notes paper, so then it will be easy for you to just to go through those ions notes paper. Then it will be easy. And then whatever doubts you are having, you can ask me Y3 plus, Y4 minus, Y2 minus. You can ask me everything. Fine. That's all for today. Fine. Thank you very much. Thank you. Bye.
Thank you, sir. Bye, sir.
Bye. Thank you.